Hello and welcome to episode 28 of Games with Go. We are in the midst of making a 2D RPG, and today we're going to try to start adding combat. Someone in chat asks, is the plan to have the monsters on their own update loop? And what do you mean? There currently is a game loop and we update the monsters on it. Are you asking if we would have like a different thread for the monsters or something? I see. So that chat is asking if we might make the monsters move when the player isn't moving. So the question would be whether we have a game that's turn-based or real-time. And my plan is to make it turn-based, so the monsters won't move until you move. So you're free to like sit and think while nothing is happening. If you're following along though and want to make a real-time variant of this, you're free to, and that would be a fun challenge. It's a little bit more complicated, but not too bad. Okay, so today we're going to do combat. There's a couple other little things we're going to take care of too. So changing the way key presses work. So currently, when you press the key down, nothing happens. It waits until you release. And that makes the input feel a little bit laggy and unresponsive because the entire key press and release takes a while. What we should be doing is as soon as you press a key, you'll move, but then it will wait until you press it again before you move again. Otherwise, you would just fly across the whole screen immediately. So that's an easy fix. And that's part of our UI. And so here we're waiting to see if the keyboard state is up and the previous keyboard state is not up. So really what we want to do is see if the keyboard state is down, and we want the previous keyboard state to not be down, to be up. Let's test that with just up to see if it looks right. Yeah. So holding up down doesn't make you fly up, but it's much more responsive. So these will all become equal, equal. And these will all become 1. And what we might want to do eventually is make a function to ask, has a key been pressed? So we can avoid having to like have this big if statement every time we want to know if a key is pressed. Because eventually we're going to have lots of keys we're looking for, and we won't want to have such a mess. So we'll make that a to-do, but we won't do it right now. All right, speed. So we gave our creatures, our monsters, a speed, but it currently doesn't work properly. They just all go one move at a time. So let's change that. And I think the way we can do it is with an action point system. So let's try it. Let's say we have AP for action points. We'll just spell it out. And that will be a float 64 as well. And that will always start at 0. And then first thing we do when we update is we will increment action points by our speed. So action points plus equals speed. Monster.action points. Okay, and then let's see. Yeah, so then what we should do is we'll get we'll truncate action points to get an integer. So if if a monster has 1.4 action points, they're only going to get to move one move this turn, and they'll retain 0.4 of their action points. If they have 2.4 action points, they'll get to move 2 times. So we'll get action points as an integer by just casting. We'll say int of m.action points. And then we can do a loop here. So for I is equal to 0 to AP int I++. And then we're going to need to keep track of where we are in our position array. So we're getting our positions from A star. That tells us where we want to go. And for now, the only place we want to go is towards the player. So we do an A star search to get a list of moves to make to get to the player. So we'll say move index is equal to 1. Because we start at 1, because the first index of our list is where the creature is already. And then rather than checking if the length of the positions is 1, we'll say if move index is less than or equal to just less than. If move index is less than the length of the positions array, then we can make another move. And we'll move to move index. And then we'll increment move index. So I think this should now let a creature move multiple times. And then every time they make a move, we also need to decrement their action points. So action points -1. Minus minus is shorthand for -1, just like plus plus is shorthand for +1. All right, let's see what this looks like. I'm not confident yet. And let's simplify. Let's simplify our room a little bit so we can see if this is working. I'm going to put one rat in here. I'm going to move the player right in there so we can test it faster. In fact, I'm going to move the rat a little closer because I think that'll be off screen. Rat, player. All right, let's try it. Okay, so there's our rat. And we're seeing the debug info from A star. So let's move. All right, did he move 2? Looks like it. Now he's on us. All right, cool. So that looks correct. Let's compare with a spider. Put a spider in there too. So the spider's speed is 1, so the spider should only move 1 at a time. Excellent. Let's try one more test. Let's make a rat speed 1.5. So we should see him move 2 squares every other sequence. So 1, 2, 1, 2. Perfect. Okay, speed now works. Yeah, cool. Okay, combat. So what we want to happen is when a player tries to move on to a monster, or when a monster tries to move on to a player, instead of moving, they will attack. And probably what should happen for an attack turn is Whoever is initiating the attack will attack first, and then whatever they're attacking can respond with its own attack. And I think for now, since we don't have any items or weapons or anything, we will just make strength dictate how much damage you do, and hit points is how many hit points you have. So we'll just subtract some function of strength from hit points. Now something we should do here is a lot of these things that we've given the monster, name, hit points, strength, speed, and action points, are also going to need to be part of the player. So for now, all player has is a position. So I think what we should do is make a character. And we'll pull all of this stuff into character. And then just embed a character. I think we can pull rune in too. I think we can pull a lot of this stuff. I think name and rune can be part of entity because everything's going to have a name. Items are going to have names. Everything's going to have some character associated with it for our level editor. And then characters are going to have hit points, strength, speed, and action points. Items like swords won't have this, but swords would have these things. So characters will have an entity embedded in them. Entities will have a position, and monsters are a character, and player is a character. So at the moment, there's really no difference between a player and a monster, but probably eventually there will be. Should POS be in character and not entity? I think it should be an entity because if there's something like an item on the map to pick up, it's going to have a position too, but it won't be a character. Okay, so this is going to cause some errors because these won't be in the right order anymore. So what we should do is just set them explicitly. This should be the rune. This is the name. What was this? Is this hit points and strength? Speed and action points. What are we missing? Need to do it this way, I think. Unknown field X in struct literal of type monster. I guess you have to do it this way. Let's see, monster's a character. Oh, we haven't, yeah, we don't make character an entity. That should be happy. Why aren't you happy? Expecting rune, comma, oh. Anyone in chat see the problem? let's try this. That's fine. Okay, we'll do it that way for now. Let's put it to do. And see why it wasn't working this way. I will probably look at that off stream so that you don't have to watch me read documentation. Unless you want to. Okay, so we'll do the same thing here for spiders. I'm going to put the rat speed back at 2. Okay, spider was S. 5.5. No, it was stronger, but slower. Okay. And then when are we creating our player? Search, search. I guess we just aren't. We're just making a level here. This is our load level function. So this is probably where we should, I guess we'll make our player here for now. And then we'll say leveled up player. Let's make ourselves a little stronger than the things we're fighting for right now. What else do we have? Speed. Okay, then we set its position right here. So that should give us a player. All right, I don't think that should affect anything yet, but I just want to make sure it still works. Yes, okay. Now let's do some combat. So the way it will work, I think we'll need 2 functions. Let's see. Maybe we can do it like this. So we'll do, we'll try this. We'll try a function called attack, which will take 2 characters. C1 and C2. And we'll keep it real simple to start, just to see if this approach is going to work. So we'll say that when we have C1 and C2, it's C1 attacking C2 first. So we'll say C2's hit points will be subtracted by C1.strength. And then if C2 is still alive, right? So if they still have more than 0 hit points, then they can strike back. So this will be like our basic attack function. And as we get more complicated, we'll have things in here that maybe we'll add some randomness to the attacks. Armor can affect things, your weapon will affect things, but this will be like the function that does it. So if a player is trying to move, if a player is trying to move and can't, because there's a monster in the way, then we know we are attacking. And player is going to be doing the attacking, and we need to figure out which monster is there. So let's actually get that from our lookup to see if one exists. So that'll be the monster that exists at the position we're trying to move to. So then we can pass monster. And let me fix something here. This should be pointers to characters. And we also need to subtract an action point here. So chat asks what sort of game we are making. We are making a 2D turn-based RPG. And you'll see it in a second here when we're going to run it. Okay, so we need to subtract action points. So as soon as C1 has attacked, we need to say subtract 1 action point. And as soon as C2 attacks, we subtract action points from them. Okay, so that way if someone's attacking and they have extra action points, they can then move again after. If not, they will not be able to. All right, we were in move. Okay, so these need to be capital player. So our level as a player, it should be a pointer to a player. Why can't we use... Oh, Go doesn't work that way. So what I was trying to do was pass a player or a monster as a star character, and you can't do that. You have to have you can do it with receiver types, but you can't do it with function arguments, I guess. So I'm going to think about that for now. We are just going to duplicate code. So player will be a pointer to a player, and M will be a pointer to a monster. And it'll be player, monster, player, monster, monster, player, monster. Then we will reverse it. And we can probably get rid of this duplication by using interfaces or something. But I'll need to think about it a little bit before we do that. And sometimes it can be good to go ahead and duplicate code a little bit. and wait until you're further along so that you know exactly how to abstract it away. So it's okay to do this, but we'll want to make a note to ourselves. That we'd rather not. Because this is going to get pretty complicated later, and we won't want to have a really complicated attack function that where we have to remember to change it in 2 places. That would be a mess. So switch our m's to p's and our p's to m. All right. So now the player will attack the monster. And then we'll need to do something to check to see if the player's dead. Then for now, we'll just do some Lost Souls style stuff here. How do we just exit? Let's see. For now, we will just panic. All right, so eventually we'll want to have some nice screen for this, but for now we're just going to print line. All right, the other side of this is monsters attacking players. So here, the monster checks to see if the player's in the way. So if they can't move, then monster attack player. Like so. And oh, we also need to check to see if the monster is dead and remove it. What's the best way to do that? So if the player kills the monster, it's pretty easy. We just remove it from the monster slice. But if the monster dies when trying to attack the player, we're in the middle of iterating over the monster slice, and we can't just remove it in place. So one way we could do it, let's see. Let's just give this a, let's test this first. Print line. We're just going to see if this is working like we expect. Crash. Where are we crashing? 131. So when we're loading our player up, oh, that's because our player used to not be a pointer. So we didn't have to create it. All right, let's see what happens. All right, player attacked monster. Let's go, man. That's us. And the rat is dead. Its hit points are -15, so it didn't attack back. But then the monster attacked us on its turn because it has extra action points and did a bajillion damage. Why did it do so much damage? That's interesting. Let's make this a little more obvious. We're just going to print out the hit points. Oh. We'll do player first both times so it's easier to see. All right, rat's coming for us. Okay, so we killed the rat. Okay, so everything makes sense. The rat did 5 damage to us because it attacked from the dead, because we're not actually killing dead things yet. All right. Ooh, we killed it. Oh, when we died. So death works. We have death as a feature now. Excellent. And it's a rough game. You just die and the program crashes. Okay, so we need to remove monsters once they're dead from the slice. So one thing you could do is we could mark them as dead and then yank them out after we've iterated through all of them. Let's see, how did we do this with the balloons? If you were here for the balloon episode, we just set it equal to exploded. Yeah, so we marked it as dead. And then I think down below, where do we actually remove it? Okay, yeah, so this is where we yanked them out. So we can do that same pattern. So let's go back to our RPG. So they're already marked as dead, which means we can just add this to the game loop. So after we've updated all our monsters, we can go through them and delete ones. So game dot monsters. Okay, so alive monsters, level monsters. So this is giving us a new slice that points to the beginning of our monster slice with 0 length. So it's pointing to the same start point, but is 0 things long. So we're going to go over all the monsters. And if monster.hitPoints is greater than 0, then we're going to add it to the slice of alive monsters. And this will happen in place. So it's going to like overwrite this array with only the alive monsters. Overwrite this slice. Oh, I forgot. Monsters is not a slice. Monsters is a map. So this is pretty easy. Yeah, this is super easy. So for position monster, so that we check to see if hit points is less than or equal to 0. Let's see, can you remove while iterating over a Golang map? I don't know. Let's see. Okay, it is safe to remove from a map while you're iterating over it. And that's really nice. A lot of collections, that isn't true. Like things go awry if you try to delete while you're iterating. But for Go maps, you can, so that's super handy. So we could even just do it in the update loop as soon as the thing is dead. So let's just do that. So we can do it right here, I think. We can say if im.hitPoints then delete from level.monsters im.position. And then we should be able to do the same thing here. All right, let's try it. Rat's gone. Spider's gone. All right, cool. Now let's beef up these things a little bit so that we actually see some back and forth. I mean, they're going to kill us now. All right, not dead. Dead. I too am almost dead. So why isn't the spider attacking me? That's a bug. Useful for me, though. Okay, and we crashed because we died. So let's see why doesn't the monster attack if we're just walking around it. So I'm just going to print out a few things here. Okay, and then I'm going to simplify the situation so we have less to look at when we're debugging. And let's see what's going on. So this tells us how many action points the spider has. This tells us the move index and the length of its A* search position list. Okay, so it's 2. So its move index is 1, its position length is 2. So it should try to move. Let's see. Maybe it is attacking, we're just not printing anything? We should be dead. Okay, it is attacking. Why am I alive? Monster attacks player. Oh, because we're not checking the player. I'm dead. Does that make sense? Is his strength high enough to kill me? Oh yeah, his strength's 100. Alright, cool. Let's make this 1 so we can test it over multiple turns. Oh, I killed him. It's too good. Darn it. Oh, he's attacking me and then immediately being killed by me. Okay. that is fine. Okay, so at this point we have the basics of an attack system. And I think what we're going to want to do next is we probably can't avoid starting to print out some text at some point. We need to be able to like list, you know, what our stats are, what our hit points are at, show what's happening, you know, that indicate that you're attacking the monster and stuff like that. So I think next episode for sure is going to be getting SDL true type set up. So you'll remember from, let's see, when we first set up SDL2 for Go, there's also all of these optional add-ons. And one of them is SDL2 TTF, which can do true type font rendering. And so once we get that set up, then we can draw text on the screen and start. It'll also make things easier to debug rather than all these print lines. So I think that'll be next. I guess the last thing I'd like to do, let's get these things combined. We got 15 minutes, I think we can do it. So let's make an interface. And in Go, interfaces are just, well, they're like they are in most languages, but it's a contract. So if something's going to be attackable, it has to provide whatever methods you list in here. So we're going to say, what are things we need? We need to be able to get action points. We need to be able to set action points. We need to be able to get and then set hit points. And we'll call this get attack power because it's not just going to be strength in the end. It'll be some combination of things. And that'll be an int as well, I think. So then what we'll do is this will just become attack. And it will take 2 attackables. And it'll just be A1 and A2. Points. Okay, so we set our action points to our current action points -1. We set our hit points of the thing being attacked to its current hit points minus the attacker's attack power. And then we can respond if we have enough hit points. So then set hit points. Set hit points and find. Get hit points. Lowercase p. Every time. Too many arguments in call to set hit points. Oh. Okay, so now the nice thing is we should only have to implement this interface for character, and then it'll automatically be available for both monsters and players, or anything else we add. We can imagine the door could become an attackable, and you could like beat the door down with your sword. So we have to implement all of these methods for character. Get action points. They're all really simple. I'm going to copy that because we're going to repeat it a bunch. Set action points. Get hit points. Set hit points. And get attack power, which for now will just return strength. Okay, so we can delete our duplicate function, delete that to do because we did it. Then we just call attack here. Player does not implement. Yes, it does. Get action points. There we go. Does not implement attackable. Wrong type for set hit points method. Ah, that doesn't return anything. Okay, now it's good. And this just becomes attack. Let's see if we still work. Put rats back at 5. And put a rat in there. All right, we killed it quick. We killed that quick too. What's our strength? Oh, 20. So yeah, we kill everything right away. Let's make it a little harder. Okay, yeah, we had to attack him twice there. Okay, great. I like that solution. So by having a character struct that's in both player and monster, we can implement interfaces on the character, and then we can pass both monsters and players to our attack function now. That will be nicer. Okay, so we got monsters that can chase us, and we can fight them. I think next step will be text, because it's going to get pretty hard to follow what's going on if we can't draw any text to the screen. So that's what we'll be doing next. Any questions about tonight's stream or previous streams? Anything at all? Just fire away in chat. I'll hang out for a minute. We do this now. This was a to-do to that we should use breadth first search to find the first floor tower and a floor tile under a player or monster or something, and we do that now. Chat asks, what about LAN multiplayer at some point? So if we do multiplayer at all, it might as well just be full internet multiplayer, since it all works the same. You still talk over sockets. Possibly. I mean, we're set up kind of in a client-server architecture anyway, with our UI and game being separate. They're talking over channels currently. Like if we look at main, right, we've got these input channels and level channels that are part of the game. And that's how the, you can think of the game as the server and the UI as the clients, and they're talking over channels. So all we have to do is talk over sockets instead, which isn't that hard. And for a turn-based game, there's really not a lot of complication. Not the kind of complications you have trying to make something like Battlegrounds multiplayer, which is really hard. So yeah, potentially we could do it, and it would be pretty easy. It'd be a ways off though. First, I want to get the ability to draw text on the screen, because that really limits a lot of what we can work on until we can do that. And then we're going to do things like do fog of war, so that you can't see all of the map until you've been there, or until you're close enough for your torch or whatever to light it up. And I also want to make a system where you can have levels that connect to each other. So you can like put in a set of stairs up or down, or a teleport thing that can link you to another level file. So we'll need to come up with a scheme for that. So you can build an entire world rather than just one map. And I want to have the ability to like design puzzles in your levels if you want to too. Like be able to put like obstacles like lava or water and have some way to solve them with crafting or something maybe. Anyway, I got lots of ideas, so if you have ideas, let me know and we'll try them out. All right, that's it for tonight. Thank you everyone for tuning in, and I'll see you next time. Bye.